If you haven't printed this out, you should print it out. Unless you're just going to look at it. You know, you can take notes instead of printing it if you want. Save some money.
You paid for it anyway.
You pay for it anyway? Yeah, that's fine. You can print it.
I've already used up most of my printing credit just between chemistry, biology, and this class.
Oh, yeah. So, I mean, if you ever feel like you just like to, if you just want to take notes instead of printing it. If you need to add money to your account, you go to the business office.
Yeah, I'm going to end up having to do that.
Yeah. It's either that or you print it on, if you have a printer at home, but it is using your printer, your ink and everything, so it's probably not too bad to print it here. But that, you said biology?
And chemistry, yeah.
And chemistry. Some of that you like it in color, right?
I mean, it might be somewhat helpful, but I print everything off in black and white.
Oh, okay.
Just to save money.
Yeah.
That's a lot of science one semester. That's a lot of science one semester.
Yeah, I like science, so it's okay.
Okay, good. All right. Okay, so these are some problems from the textbook. Modeling and functions. Section 1.10. And you're going to have a couple problems like these on the test. There's only a couple problems. So you just have to be able to work problems similar to these. A car rental agency charges $180 per week plus 25 cents per mile to rent a car. Express the weekly cost to rent a car, F, as a function of the number of miles driven during the week. X. So X is the number of miles driven. If F of X is the weekly cost. So, you want to write F of X in terms of X. So what's it say here? It says it's $180 per week plus 25 cents per mile to rent the car. Well, we're only writing this as 1 week's cost. So what's the constant? It's 180. So that's $180 plus, if it's 25 cents a mile, how much would it cost, say, to go 10 miles? It would cost $2.50. What did you do? Did you add or multiply or divide? How did you find that? Or maybe it's just you multiply it. So it's 0.25 times X. That's the cost. If you just take an example of driving 100 miles and see how much 25 cents a mile would cost. So, but anyway, that would be $25, and you multiply. So that's all you had to do. You had to translate this problem into function notation. Instead of y equals, we used function notation. Okay, so now we have the equation. How many miles did you drive during the week if the weekly cost to rent the car was $395? So we're given a weekly cost to rent the car was $395. It asked how many miles did you drive. So what are they giving us here? Are they giving us X or F of X? They're giving us F of X. Yeah. So you put 395 equals 180 plus 0.25x. subtract the 180, we're solving for x. Got this written down. When you subtract that, you get 215 equals 0.25x. Now you want to get x by itself. I'm just going to rewrite it up here. 0.25x equals 215. You're multiplying by 0.25. What do you have to do to get rid of that in front of the x? You divide. If you divide one side by that, you're going to divide the other. So x equals 215 divided by 0.25, which when you divide by a small number like that, you're going to get a bigger number. So what is 0.25 equal to as a fraction? Does anybody know? Do you have that memorized? Right, a quarter. So it's 215 divided by a quarter. 0.25 is 215 times 4. So we better get around 800. We got 860. We had to it ended up being multiplied by 4. 860. And that answer made sense. You could check it by putting it in the original equation, 860 times 0.25 plus 180. But you drove 860 miles if your weekly cost was $3.95.
Some drive.
You drove a lot of miles? Well, yeah. That's a lot in a week. Must have gone on a big road trip. I guess, I forget if it was 600 miles for me to drive to St. Louis or 800 or I don't know.
Yeah.
Doing that. Anyway, so that's how you work that problem. Another one, let's see. Here's some statistics. In 1990, 28% of babies in the United States were born to parents who were not married. Throughout the 1990s, this percentage increased by approximately 0.6 per year. 0.6%. We're expressing the percentage of babies born out of wedlock, P. So that's going to be P of X. And that's already in percent. Okay, as a function of the number of years after 1990, X. So X is the number of years after 1990. Okay. So we got to translate this into a function. So P of X equals, where do we start? They said 28% of babies in the United States were born to parents, and we're going to start X at 1990. So our initial amount, the amount we're starting at, is 28%. Remember, this is in percent already, so that's why we don't write this as 0.28. This is in percentage. Okay. Throughout the 1990s, this percentage increased by approximately 0.6 per year. So plus 0.6 times X. And it was 0.6%, but this whole thing is in percent, so we didn't have to change it to 0.006. We didn't have to change this to 0.28. All right? Just remember our answer is in percent. If this trend continues, in which year will 40% of all babies be born out of wedlock? So that's the percentage born out of wedlock. It's 40% equals 28 plus 0.6x. subtract your 28. You get 12 equals 0.6x. Then you divide by 0.6. Get x equals 12 divided by 0.6, which is 20. So, but x is not the answer. It says in which year. Remember what x started at? X equals 0 was for 1990. So you have to take 1990, the year 1990, and add 20 to it. 2010. So if this information was right, we would have expected so that we'd have 2000. In 2010, there should have been 40% of babies born out of wedlock. This is called a linear model. We're modeling this situation about the percent of babies born out of wedlock with a line. This is a line. So is this. This is a line. It's a linear model because it just has x to the first power. So that's what that is. Okay, any questions? All right. Okay, the next one's a Sam's Club kind of thing, right? We actually let our Sam's Club thing go this year. Yeah. It's very sad. I'm still carrying the card around. I just need to get rid of it. We decided it was cheaper to buy generic at Walmart than to buy the brand names discounted at Sam's Club.
Really?
It is. It is. Now, Sam's Club has some nice deals and nicer things, so we're going to
You
miss
get
that.
room to store it all.
What?
If you get room to store it all.
Yeah.
Out at a time.
Or if you can, sometimes the quantities you have to buy
That's
things
what I'm saying.
would spoil or
Yeah.
whatever. Well, anyway, we just decided. We're supposed to, in September, we're supposed to pay our fee, and we just decided not to do it. Because, well, see, I was going to pay it one day, and they said, I had upgraded to this other one that cost more money, and they said I couldn't do it except by going to the customer service, so I just decided not to do it at all. Because when I was buying, I use a lot of Listerine, so I was buying the 2 big things of Listerine, but it was actually Listerine at Sam's Club. At Walmart, I got the same size 2 things generic for less money than Sam's Club, and I was paying this $40 fee each year. So I don't know, we're going to miss it, but but we're probably not going to get it. All right, but you're choosing between 2 plans at Discount Warehouse. Plan A offers an annual membership fee of $300, and you pay 70% of the manufacturer's recommended list price. Plan B offers an annual membership of $40, and you pay 90% of the manufacturer's recommended list price. So we're going to express the total yearly amount paid to Warehouse under Plan A, F, as a function of the dollars of merchandise purchased during the year X. So X is the dollars of purchases. Or I'm just gonna, how much you spent. I should say the amount spent. That's a better way to write it. The amount spent per year. All right, and F is the amount paid to the warehouse under Plan A. So F of X, the total amount paid. So F of X equals all right, Plan A offers an annual membership fee of $300. So we got $300 plus you pay 70%. That means 0.7 times X. Whatever, however much you spend at the store in a year. Express the total yearly amount paid to the warehouse under Plan B. G as a function of the dollars in merchandise. So G of X equals our annual membership fee, $40 plus, and then we're paying 90%, 0.9 times X. Okay. I could have put parentheses or just an X. Okay. So that's the function. They're linear functions. So how many dollars of merchandise would you have to purchase in a year to pay the same amount under both plans? So you set these equal to each other. If you want to pay the same amount, this is the total amount you've paid for Plan B and A. So set these equal to each other. We have 300 plus 0.7x equals 40 plus 0.9x. We're gonna try to get all our x's on one side, our constants on the other. So if we subtract a 0.7x, we'll have a positive x on this side. So you get 300 equals 40 plus 0.2x, then subtract 40. We get 260 equals 0.2x. Divide by 0.2. So we're going to get 260 divided by 0.2. 0.2 is the same as a fifth, so we're actually multiplying by 5. So we get $1,300. So you would have to spend $1,300 on merchandise for those two plans to break even. So we didn't answer the second question. What will be the total yearly amount paid to the warehouse for each plan? So for Plan A,
Your calculator's in the way.
oh, let's get that calculator out of the way. For Plan A, we're going to do F of 1,300 equals 300 plus 0.7 times 1,300. Let's move the calculator out of the way. Do it over here. 300 plus 0.7 times 1,300. And we're paying 1,210 for each plan. If we put in 1,300 in G of X, we should get the same thing. I'll make sure, otherwise we've made a mistake. You should always check your work if you can. So G of 1,300 is 40 plus 0.9 times 1,300. And that should be 1,210 also. So let's see if that works. 40 plus 0.9 times 1,300 is 1210. So that's, they should have been equal because we set those equal, and they were. Okay. So we answered, make sure you answer the questions asked. All right, on a certain route, an airline carries 7,000 passengers per month, each paying $90. The market survey indicates that for each $1 decrease in ticket price, the airline will gain 60 passengers. Now, this is a tricky one. You want to express the number of passengers per month, N, as a function of the ticket price, X. So, the ticket price, for each $1 decrease in the ticket price, the airline will gain 60 passengers. Right now the price, let's see, the ticket price is X. So when we start out with X, say 0 equal 90. We have N of X equal to 7,000. N of X 0 to 7,000. What if our X, suppose X went down to 89? How many, say that's it. What's N of X1 going to be? We're going to have 7,000 plus, it's going to gain 60 times 1. We're going to gain 60 passengers. Every time our ticket price goes down by $1, we're going to gain another 60 passengers. What if we did X2 is 88? N of X2 is going to be 7,000 plus 60 times 2. So every time our ticket price goes down, well, we're going to have to, we need to represent our decrease in price. This right here is our decrease in price. Okay, so how do we find that number in each of these little examples? We took our original amount and subtracted the new ticket price. So our decrease in price is 90 minus X. So X is the ticket price. And we're starting out with a ticket price of $90. So 90 minus X. So if we take 90 minus 89, we get the 1. 90 minus 88, get 2. And that's how we're going to figure out our general function. N of X equals what we're starting with, 7,000 passengers, plus 60 times the decrease in price, 90 minus X. And then you can distribute, but that's the hard part. Finding that equation, this is tricky. So distribute, it's 7,000 plus 5,400 minus 60X. combine those, you get n of x equals 12,400 minus 60x. That's the number of passengers per month, n, as a function of ticket price, x. Okay, now we're going to express the monthly revenue for the route R as a function of the ticket price, x. Revenue of x, somewhere I should say. Revenue is the amount of tickets you sell times how much they paid for the tickets. Revenue is the number of tickets times the price of the tickets times price. That's what revenue is. Yeah. Okay, so revenue is going to be n of x times x. And I really want to put the x in front of it, so I'm going to put the x in front of this function, 12,400 minus 60x. R of x equals distribute, and if I write well, you get 12,400x minus 60x squared. Or you can write it, if you want, you can write it as the higher power of x plus the lower power of x. Either way, that's fine. There's the revenue. And that's x squared is the highest power of it, so it's a parabola. So the revenue is a parabola, the number of tickets, that's a linear function. What about graphically? I never talked about this. Graphically setting these equal to each other and finding what x was equal to. That's just, 300, if y equals 300 plus 0.7x, that was a line going up like this. 40 plus 0.9x was a line, and this would be 1,300. So this was where two lines crossed. Those were set to equal to each other. This is, this is a parabola. It's pointing down. The ticket cost is a line. Let's see, what would that be? 12. Okay, that goes through. It's a negative slope. See, if you put in 0 for x, you get 0, right? So I really should have. This is the 0.00, right? And it goes down, and then you've got negative 60x and 1240. I don't know. But anyway, that's just drawing some pictures. Sometimes it helps to draw some pictures. But we're not even having to we're not having to set anything equal on this example. So the picture really didn't help, but except that we maximize the revenue right up there. That would be maximum. Okay. Now that would make sense. I don't know. Maximum.
The hard part is flying a plane ticket for $90.
Oh. Yeah, really. Yeah, now you got, what, don't you have extra fees for riding on a plane? I haven't ridden on a plane in ages.
It's crazy.
Has anybody, have you ridden on planes lately?
Not because of how much it costs.
Mm-mm.
It's like maybe before 9/11, it may have been $90, but it's
Oh, yeah,
close to that now.
Yeah, you wouldn't find a flight that costs $90 would you, ever. I flew to St. Louis in 2011. One way, it was cheaper than two-way, and because I had a ride back or something with my sister. So it was at least $360. Yeah, something like that, maybe around 400.
Okay.
And that was a lot to swallow. Oh, it's a lot. Driving's expensive too, but not that expensive. Then you got the hassle. I know they throw away your toothpaste or your shampoo because it might be a bomb or whatever.
Oh,
Yeah, so you shouldn't even bring that kind of stuff with you. Or you're supposed to have it in separate little bags or something. I don't know. Okay, the last page, is this the last page of this? No, we got one more page after this. Do we need a break or do you want to keep going? How are you guys doing? Well, I can pause. Let's take a break.
Okay.
I know. Catch your mistakes on those better than catching your mistakes on the test. Okay. We're on 16. Okay, we've got an open box. We have an open box that's made from a square piece of cardboard, 30 inches on the side. We're cutting identical squares from the corners and turning them to the sides. So this is 30 inches on the side. With the square, if I just remove some amount X from each corner, that would mean I just cut this away.
It's not up on the screen yet.
Oh, yeah, thank you. Sorry, when I went in to record your grades, hopefully I hit save on them too. Oh, let's see. Okay. Okay, if I got a square, that's 30 inches on the side. This is not to scale. And then I'm cutting a corner out that's X distance. And I cut this corner out. And I cut this corner out. Since I didn't bring scissors. Okay, and I fold this up. And that's one side of the box. And then, I'd have an X and X over here. Okay, and so this is what my box would look like. Fold it up. You're just slowly removing these corners. It's an open box. So that's an open box. There we go. So I'm going to, that's what I got, a 30, the whole amount, the whole side was 30 inches before I cut anything off. It's 30 inches on a side. I'm cutting identical squares and turning up the sides. Express the volume of the box V as a function of the length of the side of the square cut from each corner, X. So we got the amount we're cutting from each corner is X. So, volume, so here's another picture. This is 30. This is 30 because it's a square. And then I'm going to cut some amount X out. And fold things up. Okay, so this is the bottom of the box, it's a square. So what is this distance? What's this distance right here? This whole distance is 30, and this is X plus X. So this is 30 minus 2X. And this is a square, so the distance here is also 30 minus 2X. So if I show it to you this way, okay, with the bottom facing us, this is 30 minus 2X, this is 30 minus 2X, and this little amount here is X. So volume is length times width times height. So we're going to have 30 minus 2X squared times X. And that's our volume. And we want to write it as V of X, as a function, V of X equals, now I'll put the X first, X times 30 minus 2X squared. And there's no reason you don't need to FOIL that out or anything. There it is. There's the volume of that box. Okay, so the best thing to do when you're trying to solve a problem is draw pictures, start tearing a few things apart. Oh, start ripping things up. There we go. Rip things. All right. So now we're going to find and interpret V of 3, V of 4, V of 5, V of 6, and V of 7. Okay, so V of 3 is 3 times 30 minus 2 times 3 squared. That's 30 minus 6. Is 3 times 24, 4 squared. Oh, where's my calculator? Didn't bring the calculator up yet? I must have closed it. All right. Okay, so 3 times 24 squared. Now you wouldn't want to multiply the 3 times 24 first. If you typing it like this, the calculator is going to do the right order of operation. Exponent and then multiply. So it took 24 squared times 3 get 1728. And that's in cubic inches. Okay. So what happens when you find B of 4? We have 4 times 30 minus 2 times 4 squared is 4 times 30 minus 8 squared is 4 times 22 squared. So the amount we're squaring is going down, but the number in front's going up. 4 times 22 squared. And we get 1936. Okay, let's do the next one. What about when we cut off 5 inches? Five times 30 minus 2 times 5 is 30 minus 10. 5 times 30 minus 10 is 5 times 20 squared. Then if you type that in, that's 2,000. And when you put in a 6, you end up with 1944. And when you put in 7, you get 1792 cubic inches. So here's what's happening to the volume as the length of the side square cut from each corner increases. Well, when we go from 3 to 4, we're increasing, to 5 increasing, and then it starts going down. So I'm right, initially as X increases, the volume increases. We have a maximum volume at X equals 5 inches. Then after 5, as X increases, the volume decreases. Okay, so that's what's happening. Okay, what's the domain of V? Find the domain. Well, here's our original square. And we keep cutting a corner off and a corner off and a corner off. And if we cut, if we cut all the way here, there'll be nothing left. If we don't cut anything off, we can't fold anything up and get a box. So your cut has to be between 0 and 15, and it can't include 15 because you'd have nothing left, no box left, no cardboard left. And so that's the domain. Okay, we're going to find the sum of two numbers is 50. So let's just call the two numbers x and y. That's our first equation. X plus y equals 50. Express the product of the numbers p as a function of one of the numbers x. So our product of x will be x times y. That's the product. But we want it all in terms of x, so we need to get rid of this y. So here they just tell us, we're just translating these into sentences. They tell us the sum of two numbers is 50. So we can write x plus y is 50. Then they want you to talk about the product of the numbers as a function of one of the numbers of x. Well, I just shown you the product of the two numbers in terms of x and y. Now we need to replace that y with something. So solve this for y. Y. Okay? Subtract your x. So you get y equals 50 minus x. So p of x is x times 50 minus x. And if you want, you can distribute it. It's fine to leave it that way. This is the product of two numbers, where the sum of the two numbers equals 50. Remember, a product means multiply. Multiply. The sum means you add the two numbers together, you get 50. So this is just translating two different things into an equation. And then you're going to replace, you're going to use this equation to solve for y over here. And replace it, substitute it in, because we wanted it just in terms of one of the numbers, x. Okay? So that's how you do that kind of problem. Okay, here's a fencing problem. You have 1,200 feet of fencing to enclose a rectangular region and subdivide it into 3 smaller rectangular regions. Fencing. Fencing is, when you're doing fencing, that's the perimeter. Spelling it right. Hope so. Okay. So we have a rectangular plot, and they're putting fencing not just around the regular perimeter of the rectangle, but they're also putting fencing here and here to divide it into 3 areas. So this is not the regular perimeter equation. What do we got here? We got an x, and we got an x here. We got 4 y's. So the perimeter of this thing with the extra fences in it, 1,200 feet, is you got 2x plus 4y. Right? You got 4 y's and 2 x's. Okay. Then it says express the area of the enclosed rectangular region A as a function of one of its dimensions, x. So here's one equation. Now we're going to have A as a function of x. And originally, what is area of a rectangle? Just the length times the width. So it's x times y. But they want it just in terms of x. So you're going to solve this equation for y. And substitute back here. To get it only in terms of one of its dimensions, x. So we solve for y, subtract 2x, 1,200 minus 2x equals 4y, divide by 4. And then you can divide a 2 out of each of these. So I'm writing it over here, y equals 1,200 minus 2x over 4. Notice you got a minus sign here, but if you divide, you can divide a 2 here, you got to divide a 2 here, and a 2 here. Or you could have seen that you could factor a 2 out of this thing and cancel or divide 2 out of But because you have a minus sign, you gotta divide the same thing out of each of these numbers. So you get 600 minus x over 2, just simplifying. So replace your y here with 600 minus x over 2. You get x times 600 minus x over 2. And that's your area. And that's what it asked for. So these last two problems, simply, they give you two equations. You have to solve one of them for y. You have to interpret, this was a product, this was an area. An area is length times width. So that's how you solve that kind of problem. Any questions on that?
Would it matter if you wrote it like that, or if you wrote it as like x times 300 minus 1/2 x?
Oh, you could write it. Oh, could you distribute this?
Yeah.
Yeah, you could write it. You could distribute it. It wouldn't matter. So if you distribute that, you'd have 600x minus x squared, and then you could divide this by 2, and this could be 1/2. You could even. Is that what you're saying?
Yeah.
Yeah, that's fine. Then you divide the 600 by 2 and get 300. Yeah, to simplify. Yeah, so it's fine. You can do it. That would be 300x minus 1/2 x squared. And that would be correct too. No problem. And then you wouldn't have had to simplify this back at this point. If you could have canceled here by separating it. Back there you could have separated it. So, okay, any other questions? So you can separate this, and you could have worked with it that way. No problem. All right, this one, you inherit, is anybody going to inherit $18,750? I don't know. Be nice, yeah. You inherit $18,750 with the stipulation that for the first year, the money must be placed in 2 investments expected to pay 10% and 12% annual interest.
How are you supposed to get those kind of interest rates?
Oh, man. Oh, they told you the investments, and I guess this is showing its age. You used to be able to get that kind of interest rate.
Now it's like 2% if you're lucky.
Yeah. And you don't want to really put it in the stock market where the stocks might fall and lose everything. So, but anyway, this is probably putting it in the stock market back in the 80s. All right. All right. So interest equals principal times rate times time. Oh. PRT or whatever. I can't remember the principal rate time. But time in this example is 1 year. The rate is a yearly rate, so you don't need the T. So you're only going to invest it for 1 year, 10% and 12%. So express the expected interest from both investments, I, is a function of the amount of money invested at 10% X. All right, well, if X, you want to define what you're doing. X is the amount invested at 10%. And Y is the amount invested at 12%. So what, we have to write Y in terms of X. So remember, X plus Y has to equal your total. So you're going to subtract your x from both sides. So y equals 18,750 minus x. Okay, so it's interest, they just want the interest. So interest for your first investment at 10% is going to be your principal, which is x, times your rate, which is 10%, is 0.10 times x. So this is your capital P is your x, and there's your rate. Plus, I'm just going to put the rate first, 0.12. That's the rate at 12%, and this is your y, the 18,750 minus x. That's your rate 2, rate 1, principal. This is your principal 2. So because the time is 1 year, we didn't need to put time in there. Okay, and then we're going to distribute .10x plus 0.12 times 18,750. If you do that on the calculator, you get 2250 minus 0.12x, and distribute. Now I'm going to, wait a minute, did I finish that? I finished that one. I'm already working on the next one. Well, that's a, oh, that's a function. All right, well, we can actually go ahead and, I'm just simplifying this, is 2250 minus 0.02x, right? Okay, so that's my interest, and that's supposed to be as a function of x. So I keep forgetting my little parentheses x. That simplifies my interest from both investments as a function of the amount of money. Okay, if the total interest earned from the year was $2,117, how much money was invested at each rate? So we're going to solve for x. And I've got my x on this side. If I subtract 2250, you get negative $133 equals negative 0.02x. Divide by negative 0.02. And x is $6,650. So you had $6,650 invested at 10%, and then you're going to take the 18,750, subtract that, $12,100 invested at 12%. Okay, so yeah, this is out of date. You don't get those kind of interest rates anymore. X is 6,650, and so that's not the answer to the question. They wanted how much money was invested at each rate. And I didn't do this. I had already figured these out, but you know, we could take 133. The 217 minus to 2250, and then divide that by negative 0.02, 6,650. If we take our 18,750 and subtract the 6,650, that's where you get the 12,001. So that's an interest problem. So interest is principal times rate times time. Any questions on that? Besides that it wasn't very realistic anymore. Rich, did you finish writing?
I didn't get the last question. Okay, I'm good.
Okay. Okay. Let's stop that. That was section 1.10.